In this video, we will look at constraints. Constraints specify conditions that need to be satisfied. Almost all the modeling tasks will have constraints. Constraints can be both 2D and 3D. Two common types of constraints are dimensional constraints and geometric constraints. Dimensional constraints focus on dimensions and include things like distances, angles, and areas. Geometric constraints focus on relationships between entities. They include things like collinearity, perpendicularity, and parallelity. In the diagram, two constraints on a building block are depicted. The first is a dimensional constraint, constraining the height of a building to be below a certain maximum. The second is a geometric constraint, constraining the edge of the building to be parallel to the site edge. In direct modeling systems, constraints are often used to limit how the model can be edited. For example, it may be possible to constrain two edges to be parallel. Subsequent attempts to rotate one edge will result in the other edge also being rotated. This type of approach requires a sophisticated constraint solver that keeps track of all constraints. In many cases, constraints can be created that become unsolvable. As a result, a message may pop up saying that constraints could not be satisfied. With procedural modeling, a simpler approach can generally be taken. Many simple constraints are naturally enforced while writing the code, in an implicit way. For example, the height and parallelity constraints could both easily be implemented as procedural code. More complex constraints can also be solved, but they may require more advanced coding techniques. Later, we will look at a few examples. Constraints and parameters are different concepts. Constraints specify a condition. Parameters specify an input. If we look at the diagram, we noted before that there was a height constraint and a parallelity constraint. Each of these constraints might make use of a parameter. So the height constraint may require the height limit to be set as a parameter. And the parallelity constraint might require the setback distance to be set as a parameter. When writing procedural code, there are many different approaches to solving constraints. We will look at three approaches. The analytical approach uses mathematics to satisfy simple constraints. The procedural approach defines a sequence of steps that lead to a solution that satisfies the constraint. The numerical approach uses a solver to search for solutions to more complex constraints. The choice of approach depends on many factors. Analytical approaches are exact and fast to calculate. But there are many types of problems where no analytical solution exists, or where developing such a solution is difficult. Procedural approaches are more flexible, and can still be fast. In general, they are also easier to implement. Numerical approaches use some kind of iterative solver. This can make them slower. But they can be used to tackle more complex types of problems. The solutions are usually approximations. So they may also be less exact. The images show a number of examples that we will look at. In the next slides, we will briefly look at an example of an analytical approach. In subsequent videos, we will look at examples of the procedural and numerical approaches. Let's look at a very simple constraint that can easily be solved mathematically. In this example, we consider a building coverage ratio, BCR, constraint. This constraint specifies the maximum area of a site that can be occupied by buildings. It is usually states as a ratio of the area of the building footprint to the area of the site. Such constraints are often specified in regulations and guidelines. One way to achieve this is to scale the site polygon so that a specific area is achieved. The scale factor can be calculated using a simple formula, as shown. The scale factor is the square root of the building footprint area over the site area. In the diagrams, the shaded polygons have exactly the required area. Many simple constraints can be solved in this way, using mathematical equations to find a specific solution that satisfies a constraint. In the next video, we will look at a more complex constraint, solved using the procedural approach.